Hello students, beginning the lecture series for superconductors as per your Btech first year syllabus. Please subscribe to the channel in order to avail the additional benefits of free notes, solution to any problem you come across while studying, free model paper fully solved before your final exam. Let us have a look at your syllabus. Superconductors. The syllabus comprises of temperature dependence of resistivity in superconducting materials, Meissner effect, which is the most important part of your syllabus. It can be asked in section C as a 10-mark question. Temperature dependence of critical field. This heading will fetch you all the numericals of superconductor. That means all numerical problems of this heading will be coming from the heading temperature dependence of critical field. Persistent current can be asked as a definition in section A. Type 1 and type 2 superconductors, once again the most important part of your syllabus, fetching you a 10-mark question in section C. Properties of high temperature superconductors can be asked, or you can be asked to give a detailed description of the applications of superconductors. So let us begin. What do you mean by the word superconductors? There are three types of materials: insulators, semiconductors, conductors, and then come the superconductors. They are divided under the criteria where the resistance decreases. So the phenomena of complete and sudden disappearance of electrical resistance observed in certain metallic elements, compounds, alloys, and ceramics at temperature around absolute zero is known as superconductivity. The very famous example being mercury below 4.2 Kelvin behaves as a superconductor. And as soon as we increase the temperature, it returns back to its normal state. This definition was asked in your paper. Define superconductivity. So this phenomena was discovered by Onnes in 1911. Materials which are exhibiting this property of superconducting state are said to be superconductors, and the temperature at which this transition from normal conducting state to superconducting state occurs is known as transition temperature or the changed temperature. So what is the temperature dependence of resistivity in superconducting materials? You can have a look at the graph and you observe from this graph that electrical resistivity, which we have taken on this axis, and temperature on the x-axis. Now have a look at the graph. Electrical resistivity of a superconducting material is decreasing when we are decreasing the temperature. And the decrease is obviously approximately a linear one. So when the temperature reaches a few degrees above absolute zero, then this element loses all its electrical resistance and they start behaving like a superconductor. This transition effect is reversible. When you will increase the temperature, it will come back to normalcy. When you will decrease the temperature, it is going to behave like a superconductor. So this temperature of a superconducting material is increased. The material transforms into a normal material, and this transition is reversible. So the electrical resistivity of certain metals and alloys which fall under the type 2 criteria of superconductor drop to zero. That is, their conductivity is very high, and when cooled to sufficiently low temperature, this phenomena is known as superconductivity. Transition temperature. This has been asked as a 2-mark question in your paper in section A. Terms like critical temperature, transition temperature, basically they mean that very point where the transition takes place from one phase to the other. We can judge that point as critical also here. TC is the critical temperature because at this temperature, the metal has changed to a superconductor, and above this temperature, again, it is behaving in its normal manner. So that specific temperature at which the material's electrical resistivity drops to zero is called critical or transition temperature. That means the change occurs at that place. It can be for temperature, it can be for magnetic field, it can be for current. Any of the same, the change point will be known as critical or transition. Below critical temperature, the material is said to be in superconducting state, and above it, the material is normal. For example, mercury below 4.15 Kelvin, the critical temperature, aluminium 1.19, tin 3.7, etc. So these definitions come in section A as 2 marks. What are the important and general properties of superconductor? This can be asked in section A. Superconductivity is a low temperature phenomena. Virtually the electrical resistance is zero, hence it can conduct current even in the absence of applied voltage. The critical or transition temperature of superconductor varies with isotopic mass, giving it an inversely proportional to the square root of its isotopic mass. This is just a property. Superconducting property of a superconducting substance does not disappear by adding impurities. And if a strong magnetic field is applied to superconductors below its critical temperature, the superconductor undergoes a transition from superconducting to normal state. And in the periodic table, those transition metals which have odd number of valence electrons show a favor towards superconductivity properties, while the even ones show it for the unfavorable ones. So what is most important here? The transition temperature, that below which or above which the effect is changing, and it is a low temperature phenomena. The resistance becomes almost zero, and the behavior of elements changes at the critical point. Next, Meissner effect. You can see how important Meissner effect is. Here you can even see what are superconductors. This must be of 2 marks. Explain the effect of magnetic field on superconductors, 8 marks. This is how these 10 marks must have been divided. What do you mean by Meissner effect? 2 marks. Explain how Meissner effect proves that superconductor is a perfectly diamagnetic material, 8 marks. What are superconductors? Describe Meissner effect. This is how much important Meissner effect is. So what is Meissner effect? Let us first define superconductor. Superconductor is a material that attains superconductivity, a state of matter where no electrical resistance is present, and electric current can persist inside it for a very long time. Meissner effect. When a weak magnetic field is applied to a superconductor at a temperature below critical temperature, the magnetic flux lines are expelled, and this effect is called Meissner effect. And this specimen starts behaving like a diamagnetic element, because when we cooled it, that is, we reached it below critical temperature, magnetic lines started getting expelled from the interior, and inside B became zero, and it started behaving like a diamagnet. This we can show mathematically also, that when B becomes zero inside, then from our very famous formula of B equal to mu naught into H plus M equal to 0, where H has become equal to the M, magnetic susceptibility becomes equal to M upon H. So the superconducting state is a perfect diamagnet if the specimen is pure and strain-free. So perfect diamagnetism and zero resistivity, they are the two independent and essential properties of superconductors. Thank you.